Hello, everyone. I hope all is well. Good afternoon, good morning, wherever you are in the world. My name is Daniel Phillips, CEO here at Industry IoT, and welcome to today's virtual business case brought to you by Industry IoT, but in collaboration with our good friends at MongoDB and Software AG. In a moment, I will bring our guest speakers up into the stream. But first of all, I'll give you a very, very quick rundown of the session. We have 60 minutes. Our speakers, Jürgen and Felix, are going to deliver an interactive presentation followed by a Q&A. Inside Crowdcast, you will see there is a section where you can ask questions directly to the speakers. If you have questions throughout, please feel free to type away. We will leave a window towards the end of the session to get through as many of the questions as we possibly can. Bear with me for a moment whilst I bring our speakers up into the stream. Felix, how you doing?
Hey, Dan, how are you? I'm very good. Thank you very much for inviting.
All good, all good. And Jürgen, hi.
Hi, Dan. How are you?
Nice to see you. So, as you guys can see from the first slide, we have Felix Reichenbach, who is currently Principal Industry Solutions at MongoDB, and Dr. Jürgen Kremer, who is the CPO for IoT and Analytics at Software AG. I know you guys as we've prepared for the session a little bit, but I will hand over to you so you can do a little bit more of a formal introduction, and we look forward to getting into the presentation. I'm going to remove myself from the stream briefly. When it's time for the Q&A, I will reappear in a little while and we can take some questions from the audience. But Jürgen, over to you.
Okay. Yeah. Hello, everyone. Great to have you on. I'm Jürgen. I'm the CPO for the business unit IoT Analytics, as Dan rightly said. So I'm responsible for the product portfolio of this strategic growth area at Software AG. That means the long-term vision and the life cycle from strategic planning to technical execution. And I'm here with Felix today. Over to you, Felix, to introduce yourself.
Thank you, Jürgen. Yes, welcome, everyone. Happy to be here. I'm basically with MongoDB for about 5 years now, and in my role as Principal Solutions, Industry Solutions, I focus on manufacturing, IoT, and use cases in that particular area, figuring out how our solutions fit into that space and how we can make it better. And I'll be happy to present together with Jürgen.
Okay, then let's get started. Felix, let me walk you through the agenda for today's webinar. We'll start with a market view on the market for connected products. Then I'll give you some customer examples. We'll talk about buy or build strategy. And then we go also into some more technical topics, architecture building blocks. And then at the end, we'll answer the question that you can put during the session already into the chat. So now let's get started with the market view of connected products. And I want to start with 3 numbers, 30, 50, and 79. Many suppliers of industrial equipment and assets like yourself have a significant install base of assets at customer sites, perhaps globally. So your customers expect you to become more efficient in maintaining these industrial assets. These numbers here are from McKinsey, and McKinsey has shown that remote asset condition monitoring can reduce your maintenance costs by up to 30%. In addition, your customers expect continuous improvements in the quality of industrial equipment you supply and the related reliability. McKinsey has also shown that remote asset condition monitoring can reduce unplanned machine downtimes by up to 50%. And to respond to these trends and remain competitive in your industry, it's of essence to ensure that your business transformation and that of your customers is successful. So clear commitment in all relevant change areas increases the chance of transformation success to 79%. And let's be clear, this is a digital transformation that you're going on here. And technology is only one dimension. For quite some companies, the North Star of their transformation efforts is the ability to also offer equipment as a service. And the equipment as a service market is emerging and growing even faster than the surrounding IoT market. Let me drop you another number. IoT Analytics, an analyst, projected the equipment as a service market to grow from $22 billion in 2019 to $131 billion by 2025, yielding a continuous average growth rate of around 35%. So roughly 5 to 8% of this revenue, 131 billion by 2025, 5 to 8% of that, that's around 10 billion US dollar, will relate to IoT platform revenues, just to sketch you that market. Now, what do we talk about? We call them equipment makers. So it's manufacturers and operators of, sometimes these manufacturers also operate the equipment. So it's equipment, machinery, and device manufacturers. And they can be found in different verticals and sectors. So not only manufacturing. And you can see some of our customer examples here. You see connected painting robots from Dürr, or connected elevators from Schindler, or connected freezers from Eppendorf, or connected excavators from Liebherr, that's the second row, or connected wind turbines from Nordex, and also connected hospital beds from Hillrom. These equipment makers, they have to continuously improve their operations, lower total cost of ownership and production costs in order to stay competitive. Therefore, they are very interested in any service that improves operational efficiencies and equipment performance. They need to understand that software has become the prime source of value generation in their business. And now these new digital business models are written in software. So they're coming from the hardware world. They are used to build the next best wind turbine or the next best painting robot. That's not any longer sufficient. They need to think software first. Thus, they need to innovate through connected customer experiences. That means software-enabled, smarter products, and value-added digital services. So these enterprises no longer just sell their industrial equipment. Now they start selling a wide range of physical equipment, plus IoT-enabled digital services. And this software-led approach helps them innovate and drive business transformation from being product-focused, from the past, to being more service-focused going forward. On the right-hand side, you see a concrete example from Dürr, who manufacture and service robotic paint stations for large car manufacturers such as BMW, Audi, Daimler, and so on. And these paint shops are operated in the plants of automotive manufacturers. So that's the end customer there. And Dürr is in the middle, the equipment maker. To differentiate, Dürr started to develop digital services that are sold together with the paint robots. One example, their app is called DXQ Equipment Analytics. You can look it up in the web if you want to see a video. And that's an app for online quality control during the painting process. And that's based on our IoT platform called Cumulocity, which you see in the middle of this sandwich there. And in that application, algorithms analyze the sensor data, such as the paint flow from the painting process in real time and detect anomalies. And this enables the operator, so the end customer, to react immediately, thus preventing car bodies from being painted incorrectly. And this is an IoT-enabled innovation that helped Dürr not only to excite new customers like BMW, but also to reduce the paint consumption per car by up to 50% in their paint shops. So let's look at some more examples in detail. The next example here is DMG Mori. DMG Mori is an international manufacturer of cutting machine tools, CNC-controlled lathes, and milling machines. These can be super big. I've been in their plants. The biggest ones are up to 12 meter high. Really impressive machines. And they have connected, DMG Mori has connected more than 10,000 machines already worldwide and are now connecting their entire fleet to Cumulocity. And DMG Mori offers connectivity free of charge. They call this the IoT connector, and they offer it free of charge in every machine as an enabler for product innovation. Cumulocity IoT enables DMG Mori now to connect their machines and their entire fleet to the platform, so they have then full transparency and can manage the machine fleet. That means they can manage the software and firmware updates, software and firmware management securely with a fail-safe update procedure. So if for example, the connectivity is disrupted because there is a network issue, that's not a problem at all. The updates of the firmware and software will automatically come up as when the connectivity is there. So this is a fail-safe update procedure that can handle connectivity and power losses. And it's highly secure, it's encrypted, and so on, which was very important for them. Then they can also collect data and analyze how their machines are used. So they gain insights into the machine usage, and which is super important for their next product generation. And through these software updates, they can also push innovation to their customers. in the form of smarter products and higher value services. Remember what I just mentioned on the slide before. That's allowing them to innovate digitally and to open that innovation to their customers. So DMG Mori's customers can then see in a portal-like application their specific machines. They see the machine status and the connectivity. They even have self-service functions, so they can configure machine parameters, define maintenance windows, and create service requests. So DMG Mori empowers their customers with these self-service tools, which also means that's reduced workloads for DMG Mori itself. And the customers benefit from increased operational efficiencies, such as reduced service and maintenance costs, reduced production weights due to better parameterization, over higher product quality to improved equipment effectiveness, up to entirely new business models, such as equipment as a service. And DMG Mori launched a new offering in that space called Pacer last year. The next example here is on field services. Flexco modernizes conveyor belt monitoring. Flexco are becoming the #1 resource for products and services that maximize belt conveyor uptime, productivity, and safety. And these conveyor belts, they can be in different verticals again. So they can be a small farm in the Midwest United States, or it can be a large mine in Eastern Europe, or a global parcel handling operation with facilities around the world. And Flexco looked for better ways to inspect and operate equipment to increase the value of their products for themselves and their customers. They wanted to preempt part failure and minimize the frequency with which engineers must enter difficult environments for on-site inspection. Imagine this is a mine, somewhere in South America. So they wanted to gain real-time visibility remotely, so into the usage and performance of the conveyor belt plates, for example, for large mining operations. Based on Cumulocity IoT, they launched a new solution called Flexco Elevate, and this offers better field services. So with this solution, they are able to discover previously hidden issues like poorly maintained equipment, which increase the likelihood of belt damages and downtimes. They have real-time dashboard that show critical events and alerts that inform their team to act and correct the issues remotely. So they are increasing then also the cleaning efficiency and reducing risks across sites. The whole solution took them only 4 months to go live, from kickoff to go live. We helped them migrate from their legacy platform to Cumulocity in such a short amount of time. And they are now globally rolling out the platform. They have already thousands of connected devices and hundreds of connected customers. And with this solution, they've saved several thousands of dollars in material and time already. They avoid costly damages to the cleaners and conveyor belts, and also increase people safety due to reduced number of dangerous conveyor visits. Now, the last example is one I really like because it's about renewable energies. Here the customer is Nordex Group, and they are one of the world's largest wind turbine manufacturers. They have installed more than 39 gigawatts of wind energy capacity in over 40 markets, and in 2021 generated around 5.4 billion euro revenue. And Nordex aims at reducing cost of energy, which is a primary KPI in the energy industry. So they want to optimize total life cycle costs of operating and managing wind farms. Nordex have built a global wind fleet control center on top of Cumulocity to enhance operation efficiency. And they replace a SCADA-based wind farm server with an IoT platform-based approach. Now, let me give you some numbers. Cumulocity powers their global wind fleet control center with more than 10,000 turbines, and they are onboarding new ones every month. Just to give you an indication, 10,000 turbines, that means we have more than 25,000 data points ingested per second, which then results in 25 terabytes of stored data in 4 weeks in the operational store. And operations are highly automated using real-time wind turbine data. Nordex also applies a consistent end-to-end architecture and standardized integration with wind turbine generators that allows the management at a local wind turbine, as well as the farm level and even global level, with the same software architecture from edge to cloud. That means we have the same APIs, the same data models, and the same analytics irrespective of the individual model of the wind turbine generator. We call this a distributed architecture. And that's a differentiator of Cumulocity. Because with Cumulocity, you can develop an application once, for example, in the cloud, and then deploy it everywhere. So from the cloud down to the edge without any re-engineering. And Nordex is using this heavily because they can pre-process data then at the wind turbine or at the wind farm level and only send higher level aggregates and related alarms to the global control center. With their new control center application, Nordex has increased energy production by between 1% and 2%, which is huge. So they reduced manually processed alarms through an automated alarm management, which increases the remote control center efficiency. Now, based on the previous examples, you can see that equipment makers gain benefits from different types of use cases, which I mapped here to a staged phase model. Each phase requires significant changes in technology, organization, and processes for the business to successfully exploit these benefits. As such, no phase can be leapfrogged without consequence. So let me walk you through these phases along the maturity curve of equipment makers. The first phase is about connecting and monitoring equipment. So historically, equipment makers have had little information about how their products are being used in the field and had to rely on users to inform them of failures and had inefficient manual processes to manage the equipment. With this remote management and monitoring, their internal field service and product development teams can incorporate live data into their service management and product evolution processes so they can build better products in the next generation. The examples given here were DMG Mori and Flexco. The second phase now turns to the customer. It refines the data-driven insights using analytics and contextual data to improve operational performance and create new digital services for customers and third-party maintenance providers. As I said, in order to compete better, equipment makers need to continuously strive to offer the highest equipment operation. So they want to improve machine uptime, lower energy consumption, increase output quality. And it's important to understand that the focus in this phase is on new external digital services, but the business model remains the same as in the first phase. But you now have the digital services bolted on. That means the equipment maker continues to sell a combination of equipment and services to the end customer as an investment and purchase, rather than anything sophisticated like a subscription model. Examples here are Flexco and Nordex. And then the third phase you see on top delivers the full equipment as a service, which is with the necessary disruption of the existing business model. So that's not a use case, it's more a business model. Increasing numbers of end customers only want to pay for defined outcomes rather than inputs. That's the big trend. They want to realize both a lower equipment TCO and have the equipment costs flexible to accommodate changes in demand. The equipment as a service business model enables the end customers to convert CapEx into OpEx and transfer the maintenance responsibility to the equipment supplier. So I'm pushing this from the end customer to the equipment makers. And to successfully offer this business model, equipment makers need to transform their entire organization. For example, service and maintenance departments turn from an independent revenue center to an important cost center. Resale and distribution networks will change. And they also need much more sophisticated metering and billing capabilities. So it's not just a technological change to get there, it's also a change of contracts, go-to-market sales force, mindset, and so on. As I mentioned, DMG Mori is an early pioneer who has paced it through all three phases. They launched their new Pacer offering last year, which allows their customers to leverage their equipment as a service with zero risk. Then, now, how can you implement these use cases? Should the equipment makers buy or build their solutions? And my answer here is neither nor. We have seen our customers and partners gain most success through the adoption of a buy and build approach. So not buy or build, but buy and build. What does it mean? We still see far too often that equipment makers, and they are engineering heavy companies, try to build their IoT solutions completely on their own from scratch. And while POCs and pilots might be successful initially, many projects fail when enterprise requirements come into play. And with enterprise requirements, I mean these things that Mongo, for example, supports. So high availability, scalability, security. And in IoT, you have to support a heterogeneity of devices, protocols, and standards. And this complexity can kill you and drives your time and effort for implementations up. So at that point, they also realize that their IoT solutions are actually products and not projects, right? That means in a product, you have a life cycle. You need to support it and maintain it, to run it 24/7, to roll it out globally. And all this requires more and more resources in terms of people and time. And most of the time is actually spent on the underlying technology. You see it here in the bottom layers, and not into code and IP that creates value for the end customer. In other words, the equipment makers, developers teams, they play around with technology like Kubernetes and messaging and time series databases that might be fun, but it's not moving the needle for their customers. And what happens is, because of this complexity, things get more and more sophisticated. You need to support all these enterprise capabilities. Eventually, the TCO explodes, and the initiatives are then stopped. So instead of building more or less their own IoT platform underneath, we believe that equipment makers should rather choose a platform like Cumulosity that provides their teams most of the functionality they need out of the box. So that's the buy part. And then they can focus on building out their differentiating solutions and services on top. That's the build part. You see it here in the top of the iceberg picture. So buy and build, to summarize, means that our customers benefit from our latest IoT platform innovation in Cumulosity, buy, and can focus their efforts on the differentiation on top. That's the build part. With fast time to value due to self-service configurable applications running on a robust, scalable platform as the foundation. So now a look under the hoods. How do the data flows look like? It looks like. And in IoT projects, you will have to tackle with different challenges to create value. First, you need to connect devices, but not only devices, also enterprise systems and other services in the cloud, on-prem, or even at the edge. So to get the relevant data for your IoT solution. And as I mentioned, you will be confronted with a variety of protocols, APIs, and connectivity options. Then you need to store and manage the IoT data coming from the devices and assets. That's the top left. And some of that data needs to be stored for years, other data only for days. Also, the granularity of the data to be stored and analyzed varies by use case. So the DUR use case, there we get updates every 8 milliseconds. Yeah, in a water management smart metering use case, you get updates every 15 minutes, one update. Totally different rates, totally different data volumes. You might need also different technologies like document databases such as MongoDB or data lakes to serve the different needs properly. Also, that comes with different costs. Other data resides in your OT and IT systems or cloud services. It needs to be integrated with the IoT device data to add context and allow for more advanced analytics. For example, you want to understand why certain anomalies occur based on the knowledge of the context. For example, did a work shift happen, or did the supplier change and that caused the quality problems, for example? You also need different flavors of analytics. Now we're moving to the middle part. Some data needs to be analyzed in near real time. That means you want to perform a live analysis of the incoming streaming data. For example, for condition monitoring use cases, you want to trigger alarms and take immediate action. Other data is stored first and analyzed after the fact, serving as a basis for KPIs being visualized in performance dashboards, BI tools, and reports. Moreover, you want to learn and train machine learning models over historic data and then deploy these models for real-time scoring to trigger proactive, predictive actions. Example use case would be predictive maintenance or anomaly detection. Another important analytical facet in IoT is time series analytics, because IoT devices generate a time series of measurements. Therefore, it's vital to deal with time series data, visualize time series data, search for patterns and correlations in there, and being able to derive rules out of that. In order to interpret this data correctly and draw the right conclusions, domain expertise is required. So for that reason, tools like TrendMiner, which you see there, which is another product from Software AG, are designed for subject matter experts, like process engineers and plant managers. So you put tools in the hands of those who understand the data and processes. And finally, now to the right-hand side, you want to integrate the insights you gained from the IoT data with your enterprise applications and workflows. For example, you want to alert the service technician via an app or a text message as soon as you identify that abnormal condition for an asset, like a wind turbine. Or you want to trigger an automated ordering of a spare part in an ERP system. In general, let me also spend a word on security that should be considered right from the start in all project steps. Another enterprise capability, and non-trivial. And security here ranges from the right connectivity options and data encryption over secure data storage, data segregation, tenant isolation, to authentication, authorization, and role-based access control. And now let me also spend a few words on why Cumulocity IoT uses MongoDB. You can see it highlighted on the slide. We use it as our operational store, and we chose it because, number one, it's flexible. It has a flexible and extensible data model that makes it simple to ingest data and to support a broad spectrum of IoT use cases. Note that each equipment maker is unique and has its specific device models and data models. And making it easy to connect new devices and ingest and access the data shortens time to market for new digital services. And Mongo, as I said, is super flexible there. The second reason is it's a robust enterprise-grade DB for mission-critical deployments, and it scales to large numbers of terabytes in our production use cases. So it includes all these cool things like HA, scalability, sharding, backup recovery, security concepts, and Felix can add many more later. Furthermore, it's offered with flexible deployment options. So Cumulocity runs in the cloud, at the edge, in distributed architectures, even still in some cases on-prem. And with MongoDB, we can do that. And also, next year, very exciting for our customers, Cumulocity IoT will leverage MongoDB's new time series feature for improved storage and faster retrieval of measurement data, which is pretty cool and will give us another boost. Now, we are ranked with Cumulocity as a leader by all relevant analysts. You see us in the leader quadrant by Gartner, by Forrester, and also MachNation. And they looked at from many different angles, from the device management angle, analytics, integration, edge cloud, security, digital twins. And yeah, we're very proud to be there as one of the leading platforms. And MachNation, that's a more specialized analyst, they even go deep and did hands-on evaluations. So they tested, for example, the performance of Cumulocity. And they ranked us number one in device management, application enablement, and edge. Now, you understand that Cumulocity enables equipment makers to connect and manage their fleets and build new services, digital services on top. The platform and its self-service tools help you to get started quickly and lay the foundation for mission-critical deployments at scale. And we have many customers that are rolling out globally because the IoT market has matured. But the differentiation needs to come from the equipment makers themselves. So from you, that's the tip of the iceberg. Yeah? We can provide you with the foundation and with self-service tools that help you capture your domain knowledge, but you need to bring your domain expertise and your IP to create these new differentiating experiences for your customers on top. And for these digital services, customers often want to combine IoT data with other business data. And for that purpose, MongoDB's new operational data layer concept can be quite attractive. And for that reason, I would like to hand over to Felix now to give you some insights into MongoDB's recent innovations and to show you how customers leverage this operational data layer.
Perfect. Thank you very much, Jürgen. And obviously, we're very proud to have such a successful company, a leader in the IoT space, using MongoDB as their backend platform. And as Jürgen said, there's always a buy part and there is always a build part, because you want to be unique. You want to be creating that specific customer experience, and you're going to need data for that. And obviously, you can talk to all different APIs spread across your enterprise tools, solutions. But in many cases, you will actually want to store data, aggregate data, and then build on top of a concept which we call operational data layer. And what that means is what I'm going to explain to you on the next couple of slides. So usually we see that here data is locked up in silos. On the left-hand side, you have all of these enterprise solutions, usually the things you buy, but also many applications you consider building, which means those are kind of your data domains. And then on the other hand, on the right-hand side, you literally have all of these different applications around your customer experience. And this environment usually moves much, much faster. There's new requirements coming up. There's a lot of competitive drive to keep you on the leading edge of these products. And it's not that easy to actually combine these two worlds. Building APIs is one approach. It's kind of the most obvious approach. But not all of the systems you see on the left-hand side are actually built to be integrated via an API. Some of them are literally have only scarce resources, limited resources. Some of them are very hard to change or integrate. It's very different technologies being used there, which makes it hard to integrate and create APIs on top of it. Some of them are monolithic, and some of them just have unsuitable license models. You don't want to integrate with these systems and suddenly have multiple applications talking directly to these systems. So how can you solve that challenge? Well, you can copy data, right? You can build APIs, but you need to copy data a little bit. And what you don't want to end up with is literally a picture like we see it here, where you're going to have different database technologies for all the different needs, the different data types, etc. And then build a lot of different ETL tools, ETL processes to move that data from one system into another. Common scenario is you have your system of record, usually a relational database. You copy data into a search engine, and then you have to talk to two APIs to fulfill your customer experience needs, such as type ahead, fuzzy matching features. And then mobile apps, just another use case. You can build APIs and bring that data to mobile devices, but for those of you who have tried to do that, it's not that simple. It's actually quite complex because mobile devices aren't always connected. And that is also a very hard challenge to solve, to come up with a great customer experience. And so MongoDB is actually a great fit for it. Jürgen mentioned it already. We have a very document model database, and document model database literally means we use JSON structures to store the data. And the JSON structures have a big advantage because they literally have the schema inside of every single record. That means you can start with a few attributes, and then over time, while the application is up and running, add additional attributes. Even if you already have millions or billions of records inside the database, you can just go ahead and add new data types, new data, and make use of that on top of your operational data layer in your specific applications. MongoDB scales well, is always on, and it runs everywhere. So independent of your cloud provider or if you want to self-manage it. And to go a little deeper into the actual architecture picture, show you how you can also segregate workloads within MongoDB. We're talking about replica sets here, which are good for scaling read workloads. And you likely have transactional workloads on the left-hand picture here, where you want to make sure that the system is up and running and that all the user interactions are actually smooth, fulfilled within milliseconds. So you can, or what people do is they usually set up a replica set. It's the best practice. The default setup is literally a 3-node replica sets for high availability, which allows you to do maintenance and everything transparently while the applications are up and running. So your end users won't feel anything, even if you change the integrations in the backend. And then there's also a lot of different workloads, primarily in the space of analytics, in-app analytics, a very popular topic at the moment, or data scientists, where we can fulfill these needs. But you want to make sure that they literally don't affect your operational workloads. So what can you do with MongoDB architecture? You literally spin up additional replica set nodes, and you isolate them. You just give certain people, certain users, certain applications access to these replica set nodes. And even if somebody downloads the whole database, for whatever reason, it literally won't affect your operational workloads, which are here on the left-hand side. So we do have Spark connectors for more the data science space. We do have a SQL API as well, which allows to plug in tools such as Tableau, Power BI. Grafana has its own MongoDB plugin. And you could also go and use the ODBC connector and pull data straight into a spreadsheet. And we obviously do also have our own solution, MongoDB Charts, mentioned up here, which uses the MongoDB query language directly on top of MongoDB data as part of our cloud product, MongoDB Atlas. If you need to scale write workloads as well, we have another option that would be a sharded architecture. I'm not going into these details in this particular session yet. What we also have, and that's maybe something you don't know, is a mobile or an embedded database. It's a super popular product. It's been developed in Denmark in around 2010, and it's gained huge traction. And there's an extremely high chance that it's actually already part of multiple of your mobile apps you use today on Android or iOS. We do have different SDKs for all the different environments and software development kits out there. And it's easy to use for developers. And that's what makes it so popular. It's object-oriented, similar to MongoDB, where we use a JSON structure, which is kind of object-oriented. Also, Realm uses an object-oriented paradigm. So that means your classes are literally your database schema. So you define your class, and you can then persist that instantiated object directly on disk. Work with it just like it is an object. Run calculations, run queries on top of it. All embedded, meaning it's a library you import into your specific application or app, mobile app. No additional deployment scenario required. It literally becomes part of your code, a part of your distinct customer differentiation. We acquired that company in 2019, and over the last 2-3 years, we've integrated it into our MongoDB Atlas cloud developer data platform with device sync. And that just makes it a native part, an extension of that operational data store to bring data to your end users, to your mobile clients, share that data, allow them to work even when they're offline, and synchronize the data with the backend across devices easily. So what is this MongoDB Atlas Developer Data Platform? And let me explain that to you on top of that picture here on the right-hand side. If you think about the document model and these JSON structures, it's literally the superset of all the other data models, right? You can store key-value pairs easily in MongoDB. You can store tables. If you look at a JSON structure and you flip it by 90 degrees, you literally have a table. You can store and query graph data, geospatial data within MongoDB. And people have been using MongoDB previously already successfully for time series data. And since that was such a popular use case, we've actually extended the product for native time series collections. And that means we've added different indexing and storage mechanisms in the backend to optimize time series processing. We added a bunch of features to actually allow you to query and work with time series data efficiently. And it's pretty impressive. We actually achieve compression ratios above 90%. And that obviously leads to a much lower footprint, faster queries, and saving costs, and not just on the storage or infrastructure side, but also on the developer side, because it's so much easier to work with these time series collections. All of these different data types are accessible through the MongoDB query language or a unified interface. And we're literally suited for operational transactional workloads or real-time analytical workloads, as seen also on Jürgen's picture. And one very unique feature, and this is really cool, I think, is Atlas Search, which is literally using the best of the search engines, which is the Lucene library underneath. And we have integrated it into MongoDB. So you can literally use your MongoDB as a system of record, and then just index the data inside of MongoDB through the Lucene index, query that Lucene index through the MongoDB API. No additional language, no additional API to talk to. You can literally just talk to MongoDB, leverage functionalities from Lucene, such as type ahead, fuzzy matching, and query the data directly out of MongoDB. No data duplication required, no additional ETL job required. It's literally just a matter of configuring the indexes for it. Super cool architecture. And then obviously a great foundation to build web, mobile, or just distributed applications on whatever cloud provider makes sense for you. We do support Azure, AWS, and GCP, and even transiently, so you can literally spin up a MongoDB cluster which spreads multiple cloud providers transparently. Security, monitoring, backup capabilities, enterprise-ready, fully integrated, as mentioned by Jürg as well. So what does that operational data store or operational data layer pattern look like? And this is something people actually apply. It's not just some crazy idea we came up with. You have the operational or the commercial solutions or the business domains on the left-hand side with all the different solutions, self-built, bought. And then you integrate these tools through ETL jobs. You can write your own, you can use tools. There's different tools who provide MongoDB connectors already today, or go for something like change data capture mechanism using, for example, Kafka, plugging into these different databases or into these different applications and bringing these change sets into MongoDB. dynamically, adding data sets, extending data sets, and then use all of these different data sets to build your application on top of MongoDB, decoupling the business domains and being able to flexibly work on top of that operational data store without having to take care of all the things which are going on in the background. Systems are replaced, new systems are added, systems are changed. You can just keep on working on your operational data store, building your application, building your features, and the customer actually literally doesn't sense anything about it. Taking device sync into the picture, you can literally plug your mobile app directly into MongoDB Atlas, synchronize data bidirectionally with an offline first paradigm. That literally means you can store and process data on your mobile app. And whenever you're connected, the cleverness of the device sync protocol will literally merge conflicts in a deterministic way, making sure that you always know what state you're going to end up, even if devices are not necessarily corrected or reconnected to the backend in the right order. And then obviously you can leverage all of the different connectors to run additional workloads and power your dashboards, your real-time insights, even if that's a customer themselves. Data ages. New things are added, things are executed, a lot of events are tracked. You still want to or have to actually track these changes, modifications which are made, but they don't necessarily need to remain in the hot, more expensive data tier. So we've built an automated data tiering mechanism, which allows you to configure rules and then archive older data, for example, based upon a timestamp, out into cheaper storage, blob storage, such as AWS S3. And we've also added another feature, because you don't want to talk to multiple API endpoints, right? So we've built data federation, which is really cool because it literally allows you to abstract multiple data sources, even if it's files on S3, if it's data in our online archive, or HTTP, HTTPS endpoints, create virtual databases, create virtual collections, map files across MongoDB clusters and files on S3, and then run your popular MongoDB aggregation pipelines on top of it, right back into MongoDB or back into, for example, S3, or just connect through the SQL connector your favorite BI tools such as Power BI or Tableau, for example. Everything pretty cool, no coding required, and a serverless architecture. Now, let me talk about a few customer examples. And one which we're very proud of is Volvo. And we're talking about Volvo trucks here. And they literally use MongoDB to track all of the events which are produced by these trucks, a lot of different events. And they've also applied that operational data layer pattern where they have their kind of IoT backend. And then they have MongoDB as an operational data store behind their web application, behind their customer services, directly used in exactly the same way I just proposed it previously. If you're interested, feel free, take a screenshot of the link, or I think we're going to share that slide deck afterwards as well, and read more about how MongoDB leverages MongoDB. Another interesting use cases, and one I like in particular, is THL Digital. And for those of you who've already rented an RV and went on vacation, this is a company you might consider if you go to Australia or New Zealand. And literally you rent an RV, and when you're on the road in a foreign country, it's not that easy to stay in contact with that company because you might not have a SIM card, right? So if you want to reach them because you have a problem, you actually have to spend quite some money just to stay in the queue for, I don't know, half an hour. Hopefully they're faster. And what they build is literally a mobile app, which is plugged into their RVs, which will help them track where you are, which will help them collect information about the RV, and which will also help people reach out or stay in contact with the RV company to fix problems on the fly, and interesting mechanisms where I'm not sure if they're actually allowed in Europe, reduce speeding tickets, share information about where potentially somebody is going to check your speed. They were very happy with that solution because it's incredibly fast and easy to build these device or mobile sync capabilities using MongoDB Atlas and the Realm SDKs. And if you're interested, again, here's the link. Go and read a little bit more about it. And then very manufacturing heavy, one of the biggest manufacturing companies in the world, also very strategic customer of MongoDB. And I do highly recommend you to look into this interesting interview between Mark Porter, our CTO, and Dirk Slama from Bosch, talking about how they use MongoDB within their different projects as well. And with that, I think we're done pretty much on time and happy to answer a couple of questions.
Good timing. Jürgen, Felix, thank you very much. Great presentation. There was just a few comments, and Felix, just to your point about sharing the deck and the links to the use cases and stuff, we can put something together to send out to all of the attendees kind of post-event, which will include a version of the deck that you guys are happy to share and any links to these customer cases, which people obviously find very, very interesting. So there have been a few questions whilst you guys have been speaking. The first one that came through wasn't directed at either one of you, so feel free to step in. But the question is, the interfaces for sensors and IoT devices with your platform, are they standardized or are they proprietary formats? I think this question came in, Jürgen, when you were speaking, so maybe it would be best for you to address this one.
Sure. The answer is both, right? There are standards out there like MQTT or OPC UA, for example, in the manufacturing area, and we support these big standards in the platform. But they'll say they are newer standards, so that's greenfield, how we call it. There, majority of deployments out there are heavily brownfield, so more than 90% are old style protocols, legacy formats, and so on, that you also need to integrate. And we do this with Cumulocity through an open source based approach. It's called thin-edge.io, so thin-edge.io. Feel free to look at the page. It's an open source project where we work with vendors of gateways and PLCs who have these protocol translators from these brownfield environments into the modern standards. And with this thin-edge.io open source approach, we help them to connect the PLCs and their protocol gateways and so on to different cloud platforms. So just to get it right, it's an open source project, and it means it's open source for everyone, but you can add closed parts. And these vendors like HMS or Kunbus or Turk or IFM, they are all part of that ecosystem, and they can add their protocol translators into the closed part of that project, enabling them to connect the gateways to different cloud platforms. Because look at the problem they have. They have these cool gateways that are attached to a machine there, right, in the shop floor. But some of their customers say, oh yes, connect this machine through your gateway to Siemens MindSphere. The next one says, yeah, for me, please connect it to AWS. The next says Cumulocity, the next says Azure, right? And with this open source approach, thin-edge.io, you can do it because it connects to different cloud platforms easily. So we support the predominant standards, but with this open source approach, we're even opening it up and allowing the ecosystem to contribute additional protocol integrations.
Thank you, Jürgen. Another question that came through: how quality would the data be, and is visualization with real-time data possible to get?
Yeah, the quality is depends highly on the use case. Yeah, and sometimes you need to do some data preparation first before you can visualize it. Sometimes data's missing. Sometimes you have redundant things in there. But there are ways to prepare the data. And then, yes, we definitely have real time. But real time is also a flexible term. How should I say, right? We have the hard real time. If you talk to MES companies, that's hard real time. They really control the manufacturing process in hard real time. The real time we use is more soft real time. That means it can take a few milliseconds or even half a second to update a dashboard or widget in there. And that's definitely possible. So we have these use cases where you have real-time dashboards that show you the recent alarms or throughput or energy being consumed. That's definitely possible.
Great, thank you. Another question that came through: what about the capability of integration with other applications in the platform?
Maybe I start and then Felix can add to it.
Sure.
Software AG, we also have a rich stack. So we are, if you want, an integration company, right? The latest addition with Cumulosity is the integration of things. So we connect now machines, assets, and so on. But for the last 10 years, we have Web Methods with its integration capabilities and also API management. So we are very much used to connect an SAP ERP system with a Salesforce and to build all these point-to-point integrations and manage the workflows. That's one way to do it. And then Felix addressed another way if you don't want these workflows and point-to-point API integrations, but rather create an operational data layer where you then build your apps on. And maybe Felix, you summarize that again.
Yeah, I think it really comes down to decoupling architecture building blocks, right? Figuring out where can you actually add and build without breaking too much or without getting into troubles because it suddenly gets extremely complex. And that's when you start segregating data, patterns like data mesh, etc., where you have different domains bringing data together through event buses, etc. And then that's where literally that operational data platform pattern comes into the play, helping you decouple, helping you gain speed, keep up with the innovation, and then stay independent of the backend systems, right? Because you're going to change them, you're going to move them, you got to do maintenance with them, and not all of them keep up and running while you do so, especially the ones with built on traditional systems.
Another question, which is MongoDB related, Felix. Can MongoDB be used in the factories for component traceability during manufacturing?
So the beauty about MongoDB is literally that you can download these the MongoDB binary, which is also used within MongoDB Atlas, and deploy it in a container or on a server and install it on the shop floor and connect it and bring data in, right? So definitely no problem. It's more of a build approach, and that's sometimes the right thing to do. And absolutely, we can support those kind of use cases.
Yeah, let me add to that, Dan, right? So this Dur use case that you saw, or also the Nordex one, there we're using MongoDB also at the edge. That means in a shop floor environment, running on an industry PC. Yeah, that's totally possible. Yes, we embedded MongoDB in the wider Cumulosity platform, but you can also use it standalone in such environments.
And we do also have interesting ways to actually integrate clusters, and there's going to be more in the future. The first release of our cluster synchronization capability just came out, which is a little bit limited for that particular scenario in the first release, but we're working hard on it to add more flexibility. And I think there's a couple of interesting architecture patterns which you can come up with as well. So if that's something you're interested in, just feel free to reach out to me, felix@mongodb.com.
Yeah, by the way, we've shared your LinkedIn profiles in the chat with the attendees, so you may get some new friend requests for people that are interested in connecting with you. There's another question that came in. So for companies selling hardware and equipment with a CapEx business model, what is your suggestion of business models and pricing if we were to integrate data and software solutions?
Oh, that's a big question. That could take a full meeting, most likely. I think you have to be aware of this whole trend towards equipment as a service. Yeah, and that also means you need to get away from this, from these one-time payments. Yeah, more into a pay-as-you-grow model. And it's the same like the software vendors like us did in the past. We had perpetual license in the past, and now we move to also to a pay-as-you-grow model. Right? And this flexibility that we nowadays also have with the hyperscalers, like you can book containers on demand, right? You can scale up and scale down. The same will happen now in manufacturing and in the industry. So you can increase or decrease your production capacity on demand. And what will happen there most likely is depending on your plans and your customers' plans. So if they have a certain capacity that they'll definitely use anyway in a year, they will most likely buy these assets, yeah, because they know it's 100% utilized. But for a certain delta on top where they don't know, yeah, maybe I get some more orders or less orders, this will be the part where they'll use the equipment as a service approach most likely. And you need to be prepared for that, yeah, to support such models from a technology, pricing, and also sales and support perspective.
Thank you, Jürgen. Felix, you have anything to add to this one, or should I move on to the next?
So I think we're very much focused on cloud right now, while maintaining the ability to actually run MongoDB wherever it makes sense for you. And if you followed the pricing strategy, which we had in the past, where we started with kind of selling nodes to RAM pools to then a fully consumption-based pricing in the cloud, which is just the way people want to consume services these days, right? So yeah, totally aligned with that.
Okay, great. There's an interesting question here, a big question, probably quite an open question at the same time. What advice would you give someone just starting their IoT journey? Common pitfalls to watch out for, tips and tricks of the trade. Again, not directed at anyone in particular, so be great to get both of your thoughts on this one.
Okay. Important is to start from the use case and the business value you create, right? There's a lot of technology out there. And as I mentioned with this buy and build, yeah, sometimes people like to play around with technology, which is cool. Felix and I also like to play around with technology, but hey, you want this project to be successful. So please make sure that you not just start with the technology, but you rather start with the use case and also a proper business case behind, so that there is real value for your enterprise or your customer's enterprise, yeah. And then, yes, look how to best support it, and don't do it stepwise, so in an incremental approach. Don't try to build the perfect solution over 3 years. Do it more with an MVP approach, and then enhance it step by step. Do a early customer validation and so on.
Yeah, I think that's very interesting, and that's also one of the reasons why MongoDB is so popular, that MVP approach, because with MongoDB you can develop extremely fast using all of the freedom and flexibility we provide. But then I think, and you mentioned that as well, it's also very important to have a kind of a picture, a larger picture, a strategy. And usually you should start with the problem you want to solve, and not necessarily just connecting that particular device you just have on your table in some way or another, but rather create that bigger picture, create kind of a roadmap, the increments which will then lead you to building strategically generic functionality which can be, or patterns which can be reapplied, and not ending up with something you will have to continuously change over every single iteration.
Maybe another point, right? So don't be afraid to ask for help, right? There have been partners, customers out there, vendors out there who have been there and ask for their advice and best practices, yeah? And that's important, because this whole IoT business is an ecosystem play. No single vendor or single company can do it all on their own. So you need your partners, right? Whether it's technology partners, hardware partners, suppliers, it's all interwoven, because you have these networks of ecosystem partners that you have to deal with today.
Good point. And we're not going to be able to get into this question into too much detail because I'm conscious of time, but maybe we can leave the listeners something that they can read up on, or maybe you can reach out to them. But there is a question that says, I'd like to dig deeper. And there's a lot of technical nuances to understand here. Is there a demo that you can share with us for both Cumulocity and MongoDB? So maybe just some info about where the attendees can find some of this information would be useful.
Yeah, I think you can simply search in Google for Cumulocity IoT trials. You can register for a free cloud trial, and you'll have, in a minute, you'll have your credentials. And then we have pre-built demos for several verticals in there, and you can start learning more about Cumulocity and the MongoDB in there, and how to build your first use cases. Just adapt the examples being provided in these trials.
Yeah, I think the same applies here, right? First of all, we have an amazing community, mongodb.com/opportunity, where there's all sorts of people, MongoDB employees, just MongoDB fans, or people interested in particular topics, and go there, ask. I think that's a great way to engage with it, similarly interested people. And then within our documentation, actually, there's references to different demo applications. And if you log into our MongoDB Atlas portal, you will actually get guided through wizards and sample applications as well. So plenty of options available, I think. And if you still haven't found what you're looking for, feel free to reach out, and I'm happy to share a few of my preferred links as well.
Great. Well, perhaps we can work together to put some links together in a document, and we can send it out to everyone that tuned in today. But that brings us up to the end of the session. Jürgen, Felix, thank you very much for delivering the presentation. Really, really interesting. We had some great comments. Actually, this is our last event of 2022, so it was a pleasure to be a part of it this afternoon. A few people have asked about the recording. We will be sharing the recording of the session over the next couple of days. We've shared links to both Jürgen and Felix LinkedIn profiles if you want to reach out to them. But as I said, we'll put a document together with some key takeaways and maybe your contact details that we can share with all of the participants. But it was great. Thank you very much, gentlemen. And we look forward to catching up with you very, very soon.
Thank you very much, Dan and Jürgen.
Thank you, Felix.
Cheers, guys. And for those of you that are interested in following industry IoT events and podcasts, please feel free to follow us on LinkedIn, Industry IoT, Twitter, and you can check out our Industrial Innovation podcast on Spotify. Thank you very much. Have a great rest of the day.